MTV, music television, debuted August 1st, 1981, promising 24 hours of music videos leading to shows like Headbangers Ball in 120 minutes, which was about 90 minutes of videos because of commercials. But anyway, it launched with Video Killed the Radio Star and the lyrics, rewritten by machine and new technology, and now I understand the problems you can see, which sounds more like DevOps killing AppSec, actually. Which means this week we talk with Manish Gupta from Shift Left about the aspect of attackability when prioritizing patches. In the news segment, smart lock and classic vulns, office macros and secure defaults, data breaches and record costs, and more. Watch the commercials and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly.
Contrast Security secures the code that global business relies on. It is the industry's most modern and comprehensive code security platform, removing security roadblock inefficiencies and empowering enterprise developers to write and release secure application code faster. The Contrast platform automatically detects vulnerabilities while developers write code, eliminates false positives, and provides how-to-fix guidance for easy and fast vulnerability remediation. Learn more about the Contrast platform at securityweekly.com/contrast security. The shift to remote and hybrid work over the past 2 years has accelerated application development on cloud infrastructure. However, securing these new assets has lagged behind. Qualys CloudView, the next generation cloud security posture management, delivers an end-to-end multi-cloud security and compliance solution encompassing the entire application lifecycle from build to runtime. CloudView enables enterprises to assess their cloud security and compliance posture, identify risks and gaps, auto-remediate issues, proactively enforce best practices, and prove compliance in audits rapidly and efficiently. Identify your most vulnerable cloud assets by visiting securityweekly.com/Qualys. Businesses need API protection that goes beyond signature matching and can stay ahead of attackers and their various tactics and tools. They need a solution that is more patient and prepared than a modern attacker and can track their actions over time. ThreatX is the only API attack protection platform that delivers on the promise of stopping API attacks in real time while giving you the visibility you need to prepare for future attacks. To learn more, visit securityweekly.com/ThreatX. This is episode 206, recorded August 1st, 2022. I'm your host, Mike Shima, and I'm here with VJ John Kinsella. Hello, John.
God, VJs. I'm just here for the CPE credits.
Sounds good. At least you remember when the M actually did stand for music in MTV. Yes. But don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. Manish has 15 plus years in cybersecurity. He was previously the chief product and security officer at FireEye, helping grow the company from approximately 70 million to more than 700 million in revenue. Prior, he was VP of product management for Cisco's $2 billion security portfolio. He also served as VP GM at McAfee, growing the network security business fivefold in 5 years. Hello, Manish. Thank you for joining us.
Hello, Mike. How are you?
Doing well, and it's great to have you back. And in fact, we've had you come back to talk about an interesting aspect of vulns and patches. And maybe I'll set up that the idea that perhaps almost all vulns are patchable, but very few of them are attackable. And I think this was a topic that that you had done some research on. So start us off with this idea of attackability or reachability and vulns.
Yeah, of course. As you pointed out, every piece of code, every software has vulnerabilities, weaknesses that can potentially be exploited from outside the application. I think the question really is, in terms of attackability or reachability, is how many of those vulnerabilities are actually attackable or reachable by an attacker. And the way you do it is you take the application, you take all of its bits and parts, open source libraries, third-party APIs, because that is collectively the application that you're going to host, let's say in the cloud. And so piecemeal analysis of just open source libraries or APIs or just custom code that the organization has written therefore eludes or is not able to accurately identify vulnerabilities. And I'll give you specific examples in just a minute. But when you analyze the application in its entirety, that is kind of what we do at Shift Left, then we look at it from the attacker's point of view, from the outside in, to see, okay, which of those weaknesses, which of those vulnerabilities in the application are actually attackable.
Yeah, I think it definitely we'll definitely come back, as you said, dig into some examples about identifying attackability. But I want to make sure we don't skip too far ahead, because there's also the part of this conversation about why do we care? Why don't we should just go patch everything is the simplest way that AppSec might walk up to a DevOps team and populate their Jira queue with a dozen, 24, 100, 1,000 vulns, just depending on how many apps they own. So walk us through a bit why we're having this conversation.
Great question. In order to sort of put application security in context, let's use an example that perhaps is more familiar to all of us who've been in security for some time, which is typically running a Nessus scan. The first time we run a Nessus scan, what typically happens? We are taken aback. We are like, what the heck did I just do? Why did I just do this? I just ran a Nessus scan and I'm finding like 1,000 vulnerabilities. Now what the heck do I do? Now that I know about them, I have to put together a plan to go upgrade those patches, upgrade so that I can eliminate those vulnerabilities. And so in the Nessus or in the infrastructure vulnerability space, we call this the dwell time. How long is a vulnerability existing in my infrastructure before I patch it? The same concept, when applied to application security, rises to the requirement that in application security, there are only two metrics, therefore, that are paramount. One, what percentage of vulnerabilities are we able to fix? And how quickly, or the mean time to repair or dwell time, how quickly are we fixing? Unfortunately, even though application security has been around 20 plus years, look, most of the folks that I meet who've been running application security, the things that they measure are how many vulnerabilities are they finding. You ask anyone, hey, okay, tell me, what is your fix rate? What percentage of vulnerabilities are you fixing? Or what is your mean time to repair? And you would, for the most part, get blank looks like, I don't know. And so that is why attackability is important, is because in this, if we are to run an application security scan, very much like a Nessus scan, we're going to get hundreds and thousands of vulnerabilities. And left on their own, they're never going to get upgraded, because it's a lot of technical debt, and fixing an application security vulnerability is harder for the most part than fixing an infrastructure vulnerability, which is why we need attackability, or we need notions like attackability to pinpoint exactly which ones are truly attackable from the outside so that we can prioritize and fix them.
Yeah, and that prioritization is absolutely where the key of this conversation, because you touched on that dimension of time. So there is what's mean time to fix, mean time to repair, how quickly can you fix the vulns that you identify. But the reason for prioritization, just to emphasize that point, is that it takes time to fix those vulns as well. It's not just we're waiting around 11 days and on the 12th day we'll fix it perhaps, or maybe it is as simple to fix, but doing some analysis, doing even potentially refactoring. I may trigger John by using that word, or just re-architecting, or just figuring out what's going to break if we upgrade. Those are developer time. So maybe now we can go to some examples you have, or talk about how does in practice this idea of prioritization and saying, well, only fix these couple of apps, start to help the developer side of things, rather than just we're talking about AppSec all the time.
Yeah, indeed. And this example, it's easier to explain an example using an open source library vulnerability, even though the notion of attackability applies to any kind of vulnerability in an application, be it a vulnerable library, be it a vulnerability in custom code created by the organization's developers. But let's take an example where there's a very simple application and it has only one API. Therefore, anyone, and therefore an attacker, can only talk to this application through this one API. Now, in this application, again, to keep the example simple, there are two vulnerable libraries. One vulnerable library, and both have the same severity of vulnerability. One vulnerable library is in the path of the API. If I follow the API input, it touches this vulnerable library and it touches the vulnerable function of that library. Therefore, as you can see from the outside in, clearly an attacker can reach this vulnerable library. Hence, it is attackable. Conversely, if you were to look at the other vulnerable library that happens to exist in this application, it is not in the path of this API. And no matter how hard the attacker tries, he cannot reach this vulnerable library, and therefore it is not attackable. Now, typically in application security, SCA, software composition analysis tools, technology that has been around for some time, largely prioritizes based on the severity of the vulnerability. In this particular case, both of those vulnerable libraries would be highlighted as of equal importance to fix because they have the same severity of vulnerability. Looking at or leveraging attackability, we are now told that, hey, look, fix the first one and you don't have to fix the second one. Now, when we apply this logic to all our customers, as we did in this report that we recently published, we find that only 3% of vulnerable libraries are attackable. Only 3%. It's huge, meaning 97% of the times our customers, developers are being asked to fix or upgrade vulnerable libraries that are not attackable.
That's pretty amazing. And I think, on the one hand, to me, I would look at that and think, what a time saver. Can I just never, not deal with this at all? Want to explore a little bit of that time dimension, though, because I can imagine even me, and perhaps some of our listeners too, might start to get a little uncomfortable in the idea of, you don't have to fix this, because there's still a software quality issue underlying this, though. So as you see that, does it turn into that very binary case of fix these, but you don't have to fix these because they're not attackable, which maybe we can explore that a little bit too. Or, how does maybe that spectrum of time, how have you seen the most important ones get fixed over this period, and what's the other time window for this long tail of all the other stuff that's not attackable?
Yeah, you're indeed right. And I do not want to come across as saying that if a vulnerable library is not attackable, one should not upgrade it. And in other words, if you are an organization and you're listening to this, if you are an organization that is able to upgrade all your vulnerable libraries, well, guess what? Attackability probably does not have much use for you. But I am yet to meet an organization that is able to upgrade all their vulnerable libraries. And therefore, everyone needs attackability to help them prioritize. In terms of the time advantage, so what we find is across our customers, again, they're able to fix 76% of vulnerabilities in less than 12 days. 76% in less than 12 days, which is typically a sprint in most companies, and leveraging this attackability. Because imagine if all three of us were developers and we were writing one application and there were 10 libraries that are vulnerable in this application that we're writing together. We are scenario number one, which sort of exists today, minus the concept of attackability. We are all given 10 libraries that we got to upgrade. We have a release to meet. It's due in about a month. So that's scenario number one. Scenario number two, the same 10 libraries, we use attackability concept, and using that same 97%, we're going to get one library that we got to upgrade because that's attackable. Clearly, as you can imagine, scenario two is preferred, where we can quickly upgrade one vulnerable library that is attackable and put the other 9 that should be upgraded in sort of what I would call hygiene. Let's fix them when we can. That's the second part. Now, the third very important part that stems from all of this attackability analysis that we do today in the industry, there is no alternative when a vulnerable library is found there is no alternative to upgrading it to eliminate that vulnerability, right? It's either if there's a patched version available, everyone is just asked to upgrade it. But many a times, an organization is not able to upgrade a vulnerable library because perhaps they started using this 3-4 years ago. There have been a lot of releases in the middle. The APIs are not compatible. It's a huge amount of refactoring, recoding in order to upgrade the library. Now, attackability in case of shift left goes from the point where the tainted input can come in to a sink that can be exploited. So therefore, that entire code flow is provided to the developer. So the developer can himself choose, oh, if I were not to upgrade this library, and if I were to somehow sanitize this tainted input before I submit it into this vulnerable library, guess what? I've eliminated the vulnerability.
Yeah, it sounds like also now the attackability is giving, as you described, more information to the developers too. That's actionable. That says how we're basically having a risk conversation. How long can I tolerate having this vuln out there, et cetera, which I think is speaking to a bit of what's the maturity of the org. Like you're talking to, not many organizations out there can just update all of their applications within 1 or 2 sprints. Not all of them have an asset inventory. These are degrees of maturity. And one of the aspects, coming back to the idea of risk, and more mature organizations, perhaps, there's also an aspect of attackability in the sense of, we're describing this is exposed to the internet. So it's going to light up if you have a bug bounty program that starts finding all these issues. But there might also be, service to service types of publicness, if you will. I'll call exposure is probably a better word to use there. But this is, a microservice might be exposed to another microservice that is vulnerable. So you might have a hard, crunchy outer edge, but a soft internal. So how do you kind of then mature the conversation of those risk evaluations and attackability to bring those into consideration as well?
Yeah. I actually and I'll reinforce one thing that you mentioned, Mike, which is risk prioritization. And yes, indeed, attackability is another name for risk-based prioritization in this case. Coming to your point about, coming to your point,
we're getting CISA conversation about the risk.
That's right. So coming to your point about whether the application or the microservice in question is indeed internet-facing or is middleware or backend, that's something today in the notion of application security, tools do not get to see. Because application security typically takes an application, a microservice, which could be one of many microservices that together comprise an application. We take one microservice by one microservice to be able to analyze it. And therefore, whether this information, whether it is internet facing or not, usually application security tools do not have. But that is the future of application security. That has to be a point where application security tools have to evolve. And we see this today in the industry. There are 2 sets of broadly classified within the world of application security. There are sort of 2 broadly classified sets of technologies. One that look at the applications from the outside in, i.e., if I have 100 microservices running in my AWS, they would look at, okay, how do these 100 microservices talk to each other? Which one is internet facing? That's one perspective. And the other perspective is brought by application security analysis tools like Shift Left, who are more looking at the code. And so these runtime visibility tools and code analysis tools like ours, today, they are separate. They don't share information. And that is the next step, where we and these runtime tools share this information so that the customer is given one dashboard to say, hey, here are your 100 microservices. This is how they're deployed. And these are 10, for example, that are internet facing. And from code analysis tools, here are the number of vulnerabilities in each one of these microservices. So with that view, I think we land up helping customers a lot, because now, precisely to your question, we have an additional context, which is yes, this is a vulnerable application. The vulnerability is indeed attackable. And now, from runtime visibility tools, it is indeed internet facing.
Oh, that makes sense. Just to try to bring, we have these signals about risk, and what you've also described too, which I think is helpful to the developer side, is that these signals about risk are coming from tools. Meaning the developer doesn't have to paint the application with a particular label, with a particular business context, even though that business context honestly might be pretty helpful as part of this risk conversation. So what kind of conversations have you seen around evaluating risk from different organizations, whether they're small, large, low maturity or high maturity in this area?
Yeah, great question. What we find across our customer base is that there are certain aspects that help an organization sort of achieve higher, better, improved fix rates. And those are, first of all, is the scan frequency or development frequency. The higher the number of changes made, higher the number of pull requests being made in a particular organization, higher the fix rate. And that's very counterintuitive. Typically, application security is viewed as, or application security views software development speed as, hey, if my organization was doing one release in 6 months and they were not fixing enough vulnerabilities, now that they're doing one release a month, clearly my situation is going to get far worse. In fact, it's just the opposite. And the reason why that happens is I'm looking at the quizzical look that John has, and so I'll explain further. So typically, shift left-like tools are embedded in the very far left, hence the term shift left, very far left of the software development cycle. Ideal place is within the private branch of a developer, meaning every time, like three of us, for example, again, we are working on one application, but not every change that we make, we directly merge it in the main branch. We have a copy of the code on our own machine, and we make these incremental feature pushes. And at some point, maybe at the end of the day or tomorrow, we merge it in the main branch. So if we were to run shift left like code analysis tool, every time we made a change within our own private branch, and we are able to provide developers vulnerabilities accurately using the attackability notion very quickly. Average scan time across all our customer applications last year was 90 seconds. So imagine I made a change within 90 seconds. I'm told, Manish, this change that you made caused these two vulnerabilities. And guess what? Even further, application security has put a rule that this particular application deals with customer sensitive data and therefore should not have any code injection vulnerabilities. Out of the two vulnerabilities, one is code injection. That has to be fixed. So well before the code is even merged into the main branch, I get to fix it.
Yeah, one of the things I like about that aspect too of putting as close to the developer as possible is is that if it's the developer that committed the code, they're conceivably also the one who should be fixing it, or at least has the context about what that code was trying to do in the first place. That's a problem if you wait later, or honestly as well, if you have legacy systems where, great, we found a vulnerability in this code. Does anybody remember who wrote this application? Does anybody own this?
Right.
So there's still this legacy aspect too, or maybe unowned or tech debt, whatever particular metaphor you want to use for it. When you look at those fix rates or time to fix, how does that legacy or tech debt aspect of the unowned or very rarely touched code impact those types of situations? And does attackability still have the same importance for those, or should we be thinking about something else in those scenarios?
Yeah, and you get to see this in the lifetime of a customer's journey. So what I mean is customers who've been using some legacy application security tools and have not been fixing vulnerabilities fast enough, have accumulated technical debt over a period of years. Then they start using shift left. Now, initially, most organizations, in fact, all that we've worked with, their priority first is to make sure, because it's a new tool, it's a new process, that they are trying to put in place between application security and developers. And so they want to only focus on the new vulnerabilities first. They want to make sure that this notion that a developer does the change, the developer is informed of the vulnerabilities well before even Jira gets to know about it, well before even application security ever gets to see it and is able to fix. Let's just get this working for new vulnerabilities. And that is the statistic that I shared earlier. 76% of new vulnerabilities are fixed within 12 days. Now, once this process is in place and it is working, with legacy application security tools, the other thing that we see is there's lack of trust between application security and developers for the most part. Actually, they hate each other because both of them have very different criteria of success. And so that confidence has to come between those two teams. This is what I like to call establishing of DevSecOps. Because isn't that what it is? Which is developers are developing in a very agile manner. We have not had to hire hundreds and hundreds of application security specialists. We can leverage the staff we have, use technology to create this automation. And then once the organization starts to fix new vulnerabilities at an improved rate, and that culture is set in, that is when these organizations then say, okay, now that we've started to do the new vulnerabilities really well, let's go back and start taking care of technical debt.
That makes sense. And that sounds go ahead, John.
I want to jump in there for a second, if you don't mind. And I'm still thinking about that comment a few minutes back, which had the quizzical look, Manish. And sort of bringing that together, what we're just talking about is when you're the patterns you're seeing from these users that are developers as they are when they're not my enemy, by the way, but as they increase, I'll say, frequency of those PRs, is it purely that there's a tool there which is helping? And I mean, the tool is great. Don't get me wrong. Especially I like the idea of having being able to do that scan in 90 seconds. That makes my heart just burst versus some of the tools I use now, which might be 9 minutes. But I'm guessing there's also some amount of what I'd love to hear is there's some amount of, I'd say, a culture in the company that they're both more familiar with the code, they're more familiar with the PR process, they're more comfortable at actually making that change. So now that they've got that level of comfort, and then they either bring a new tool in like yours, or they've replaced another tool with yours, or however you want to look at it, it feels like there's sort of a bit of a step function going on there, right? They've got the base, they're good developers, they have a good hygiene processes, they care about the security of their code, and now they're putting this tool on top, and they've got this sort of overall layer of cake that sounds great. Are you seeing that, or is it just one piece of that?
You're right. Look, there has to be a willingness, there has to be a desire to try and improve on application security practices that exist today in an organization. And perhaps because it's only organizations that are wanting to get better, reduce application security risk, that they'll talk to us. Perhaps it's a self fulfilling prophecy in that respect, that I don't get to talk to organizations who don't want to improve application security. So, assuming that desire is there, that business goal is there, that we got to reduce application security risk, and perhaps we could ask, what causes it. And what we find is that the reasons this notion comes in is that whatever we're doing for the last 5-10 years isn't going to work anymore, is typically digital transformation. And it has many different flavors. An organization, for example, that has never deployed code in AWS or in the cloud, and now has a roadmap, clearly sees now that their code, their applications are now directly going to be internet facing. They don't have those 2 layers of firewalls and intrusion prevention that they had in their own private data center. They've lost a lot of that control. Now, so that's part one. Part two is, as soon as someone's starting to use cloud-based tools, you're going to need to now hire developers who are familiar with deploying in these cloud-based technologies. And these developers inherently want to use modern tools. They want to use GitHub, they want to use third-party libraries, they want to develop to S3 bucket, API, etc. And so there is this inherent need for the organization to move faster, to start using CI/CD. And as soon as the word CI/CD comes into the equation, as soon as like, hey, we need to release faster comes into the equation, that is when the organization really realizes, man, whatever I was using in the past isn't going to work. Now, the other thing that I would say is, look, this is not just about speed. 90 seconds of scan time, that is not the only element. If we look at all the factors that have to be in place before an organization's fix rate goes higher, we find they are. One is accuracy, which is what we call attackability. Because I could scan in 60 seconds, but if I gave you 100 vulnerabilities every time I ran a scan, no good. So it has to be highly prioritized, risk-based, scan time. Third is it has to be deeply inserted into the developer workflow. I should be seeing the vulnerability that my code caused within the GitHub or GitLab or Jenkins or Jira or whatever tool that I want to use. If you ask me to go use some third-party tool, which is an application security dashboard, never going to happen. So that's the third element. Fourth element has to be, as a developer, I need to be told, not by a person knocking on my cubicle, but through these technologies, which vulnerabilities for this particular microservice, for this particular application are important and which ones are not. And so in all of these and the fifth part I should also add is that deep visibility, deep and accurate visibility with line numbers and code from the start, which is the input of the taint to the sink. I should just, when you tell me that this is a vulnerability, I should be able to look at those 6 lines of code and say, that is why this vulnerability is being highlighted to me. And lastly is the training and contextual information. As I often say, my son did a undergrad in computer science and he never took a security course.
Uh-oh.
and that is generally the case. So, the tool just told me, hey, there's a SQL injection vulnerability. I might not even know what is a SQL injection vulnerability. I might not know what is the best practice to fix it. So all of those things should be at my fingertips. Yeah. And this entire set of requirements are in place is when fix rate goes higher. It's not one or the other.
Yeah. And it's interesting just to cap on that. And, I haven't seen your guys' tool yet. Maybe I should demo it. But it's not just, the more information you can get there at that end point is if I can get the line number, which for our listeners, depending on the language we're talking about here, that can be significantly more difficult than it sounds like it is. But getting the line number where that's coming from, and then like, hey, this is SQLi. By the way, this is how someone could attack it, and this is the type of thing you should probably need to do to fix it.
Exactly.
Because as you're saying, it's not just the developers want to use the new tools, but they want to learn, right? And like, so if we can do that thing which our colleges are not doing and actually educate them about security, I can see that being quite powerful to a lot of developers. Cool.
Part of that also brings up to my mind, Manish, our friends over on the developer side. You've been talking about fix rates, for example, as a metric, and I strongly agree why and understand why you're focusing on that. But talking about having shared success metrics or shared goals, should we be also, in addition to fix rate, should we be also talking about a good target for the number of days to start fixing vulns or the number of vulns that are found? And the reason, maybe it's a bit of it is a loaded question, because I also want to make sure that we avoid having the wrong metrics that we have shared friendly goals with, and we're actually doing something that's going to help both sides of that equation.
Yeah, you're absolutely right. The fix, percentage fix or fix rate is a metric that application security loves. Developers like the metric of mean time to repair. How quickly are they able to fix a vulnerability? So what we don't know of, or it is hard for me to come up with like what should be the fix rate, what percentage of vulnerabilities should you be able to fix, and what should be the mean time to repair. Across our customers, as I said earlier, it is 76% in 12 days. For some organizations, like some of our leading edge, like there's a fintech company which is doing about 30,000 scans a month with us. 30,000 scans a month. Their fix rate is 95%. Their mean time to repair is 5 days. And so clearly, therefore, there are organizations. There's a 150-year-old company that is one of our customers. Their scan rate is much lower. Their fix rate is much lower. So I think as in terms of goal, what I like to suggest is that there has to be a goal, not in absolute terms, but in relative terms. If my fix rate today is 20%, how do I get it to 30%? If my mean time to repair is a year, how do I get it to 6 months? Now, where we as Shift Left need to help our customers is we need to be able to provide our customers with a cohort analysis. So, for example, if there are 10 finance customers that we have, I, as one finance company which is using Shift Left, should be able to know, hey, what are my other peers doing? So that I can measure them myself against them. In cybersecurity, it is often said, right, in the jungle, I only have to run faster than my brother. And so I think that notion applies equally well here.
Well, another notion that equally applies is we have a mean time for these episodes that we're running towards the end of. And I don't want to outrun both you and John, but I do want to say thank you for joining us, Manish. If one last question, perhaps, though, you talked about, AppSec 5-10 years ago wasn't really working. We're getting hopefully better now. And you did touch on a little bit just of comp sci and security. What might be one or two topics that you'd love to see 5 to 10 years from now within the college education, within the university systems? What kind of security topics should they be teaching?
Mike, I actually have given up on that notion on that hope that we can actually do this in universities. I find that the industry is moving at a much faster pace. The number of new languages that we tend to use, and the kinds of vulnerabilities, the whole CI/CD, the whole development, software development, using low code, no code. I think that horse has left the barn. And I don't think universities can really catch up. I think what I would love to see for universities is just to emphasize in software development the importance of cybersecurity. And if we plant that seed, I think we would have done a great first step. Then the developers, when they go out in the workplace, they know that, oh, wow, I need to write code, but I also need to write it securely. I am using Scala, for example, and what are the security best practices? Let me go learn that on my own. Perhaps the organization could provide me some tools. But now I've given up on the notion that universities can actually do this in entirety.
Interesting. Well, you've definitely planted the seed for another full 30 minutes of conversation we're going to have on that topic, because now I've got a whole bunch of questions, but unfortunately I'm just going to have to say thank you once again rather than to diving into them. So thank you, John. Thank you for Manish for joining us. Thank you for everyone listening. We're going to take a quick break and return with news of the week.